Hey guys, this is part 2 of our factoring video. So if you haven't seen part 1 and you don't feel comfortable with factoring out the greatest common factor or factoring by grouping, make sure you look at that. So we're going to be using both those techniques to factor quadratics, which are ax squared plus bx plus c, in part 2, which is this video, and then in the next part we'll look at special products, which we'll get to in part 3. So for now, let's look at factoring ax squared plus bx plus c. So factoring ax squared plus bx plus c breaks down into two separate cases. So the first case we're going to look at is a simpler one, and that's when a equals 1. So now instead of ax squared plus bx plus c, we should have x squared plus bx plus c. And the idea is if we want to factor this, the only way we're going to be able to factor a quadratic is to factor it in the two linears. So we're going to have something that looks like this. Alright, these x's are going to multiply and give us the 1x squared that we want, and then this stuff will give us the rest of the quadratic. Alright, if we had any extra terms, we would get something that's bigger than x squared, which we don't want because we only have a quadratic. Now, if we factor or multiply this out, if we FOIL this, we get x squared. Alright, the outer ones give us ex, the inner ones give us plus dx, and the last ones give us de. Another way we can write this is x squared, and then from these two middle terms, you can factor out an x. So that's factoring out the greatest common factor just from those. We're left with e plus d, and then still plus this de. So now if we were to factor this x squared plus bx plus c into x plus d and x plus e, so we want these two last pieces to match up. So we want x squared plus bx plus c to match up to x squared plus x times e plus d plus de. So what's that mean? That means we need this term here, what's being multiplied by the x. Well, that's originally b, but in here it's e plus d. And we need this last term, our constant term. Well, originally that's c. Alright, and that needs to be equal to de. So here's how we get a general method for factoring x squared plus bx plus c. We find two numbers, we'll just call them e and d for now, that add up to give b, and then multiply together to give c. Alright, and then we're just going to throw them at the end of these linear terms. So once we get d and e, we'll just do x plus d times x plus c. So let's look at an example and see how that works. So we have this first example, which is x squared plus 5x plus 6. So the first thing we're going to figure out what our b and our c are. So b is whatever is the coefficient of the x term. So here b equals 5. And then c is whatever the constant term is. So c equals 6. So we want to find two numbers that multiply together to give c and add together to give b. So the only options we have here for 6 are 6 times 1 and 2 times 3. So you can immediately see 6 times 1 adds up to give 7, and 2 times 3 adds up to give 5. So what we're going to use is the 2 and the 3. So this is going to be equal to x plus 2 times x plus 3, since they are both positive here. So now let's look at another example. There's a couple little nuances you can see with the addition, whether these are addition or subtraction, and we'll see those in the next example. So for the last example, I instantly knew that I had x plus 2 and x plus 3. So let's see why I knew that those were both positive. So here we have something a little bit different. We have x squared minus 9x plus 14. And remember, our final goal is we're going to have some x plus d times x plus e, and that gives us x squared plus x times d plus e plus de. So from this expression and the expression I want to get, I can see a couple of things. Firstly, d times e gives me this c. So d times e needs to give me positive 14. So the only way to take two numbers and get a positive number is either they're both going to be positive or they're both going to be negative. Alright, so that's the first thing I need. Whenever I see a plus in front of the constant term, I know they're both going to be negative or they're both going to be positive. Now I can figure out which one of those I want, because I know they have to add up to give me negative 9x. Well, I need to add d plus e to give negative 9. If they're both positive, I can only get a positive number out of that. So now I know they both have to be negative. So this first plus tells me they're both the same sign, and the second sign tells me that they're both negative. Alright, so now let's do the rest of the problem knowing that. So now we know that b is negative 9, and that c is positive 14. Well, if we look at the factors of 14, we got 14 times 1, and again they're both going to be negative, so I really have negative 14 and negative 1. Those add up to negative 15, so those are out. The second two are negative 7 and negative 2. Those multiply together to give 14, and they add together to give negative 9. So now I know my final answer. My D is negative 7, so I have x minus 7. And my E is negative 2, so I have x minus 2. And again, just to be safe, you could factor or FOIL this out one more time to make sure you get back what you started with, but you'll get an x squared, a minus 7x plus a negative 2x, that'll give you negative 9x, and then negative 7 times negative 2 will give you the plus 14 that you want. Now let's look at one more example when a equals 1, and we'll have a negative here instead of a positive. Alright, so this is the last example for the a equals 1 case, but now we have a negative in front of the constant term. So what's the only way that can happen? Well, we know we're going to find a d and an e, and those are going to multiply together to give de. So the only way two numbers can multiply to give a negative is that one of them has to be negative and one of them has to be positive. Alright, so we need one negative and one positive. So now we're going to look at our b and our c again. Well, b is negative 5 and c equals negative 14. Alright, so we just looked at the factors of 14, so we have 4 times 1 and 7 times 2. But again, now we know that one of them has to be negative and one of them has to be positive. Well, we just have to check all the combinations. So negative 14 and positive 1 add up to negative 13. That's not what we want. Positive 14, negative 1 is positive 13. That's not what we want. But now if we look at negative 7 and positive 2, those are going to add up to negative 5, which is exactly what we want, and they're also going to multiply to negative 14, which you want. So now we know our factoring is going to be an x minus 7. Alright, so we want the negative 7 and then x plus a 2. Alright, and again, if you factor or FOIL these out, you'll get back to x squared minus 5x minus 14. So these signs are really helpful. If you have a plus, they're both negative or both positive. A minus means one positive and one negative. And then you just use that information to figure out which two add together to give your b that you need here. So now we're going to move on to the slightly harder examples, which instead of having a 1 in front of x squared, we're actually going to have some other real number. Okay, so now we're going to look at case 2 of factoring ax squared plus bx plus c. And that's when a is not equal to 1, so now we actually have to worry about what this is. And the technique to start is going to be pretty much the same thing. Now we're going to find two numbers b and e, or d and e, that add up to b. And the only difference we're going to make now, instead of multiplying to give c, they're going to multiply to give ac. Alright, so same idea. We're going to figure out two numbers that add together to give b and multiply together, but now we're going to multiply together to give ac. And what we're going to do is we're going to replace this term up here where we know e plus d is b, so we're going to rewrite this as ax squared plus, and now instead of bx, we're going to do ex plus dx. Alright, we know e plus d is the same as b, so ex's plus dx's give us bx's, and we'll have this plus c. And now we have these four terms, and what we're going to do is we're going to group the first two together, and group the second two together, and then do factoring by grouping, and that should give us two linear terms at the end. So now let's look at two examples, and we'll see how to do this method for factoring ax squared plus bx plus c. So for this first example, we want to factor 2x squared plus 5x plus 2. And again, now we're just going to find our b and our ac. So b, again, just the coefficient of x is 5. Alright, then a times c. A is going to be the coefficient of x squared. Here it's 2. C is the constant term, and that's 2 as well. So we know AC is 4. So now we want to find two numbers that multiply together to give 4 and add together to give 5. Well, 2 times 2 doesn't work because that's 4. But 4 times 1 are going to be the choices that we want. So 4 times 1 multiply together to give 4, and then if we add these together, we get 5. So now we're going to use our 4 and our 1, and we're going to write this as 2x squared. Now instead of 5x, we're going to write it as 4x plus 1x, and then we still have this plus 2 at the end. Alright, so now we turned this trinomial, alright, with 3 terms into something with 4 terms, and now that we have 4 terms, we can do factoring by grouping. So we're going to factor or group these first two together and group these second two together, and we'll factor out as much as we can. So in this first one, we can factor out a 2 and an x. That leaves me with an x here and a 2 here. Right. From the second term, I can't factor out anything. Alright, so I'm just left with x plus 2. Alright, but now you can see on the left hand side of the addition we have an x plus 2. On the right hand side of the addition we have an x plus 2. So I'm going to factor that out. And in this first term I'm left with 2x. And again, remember, if I factor out an x plus 2 from an x plus 2, I'm left with a 1 and not a 0. So just be careful with that. Now if I factor this quadratic here, I should get x plus 2 times 2x plus 1. And if you FOIL this out, you'll get back to what you started with. So this is the last example for this video, and we want to factor 15x squared minus 14x plus 3. So again, same idea. We're going to take this b, which is negative 14, so don't forget to include signs, and then AC, A is 15, C is positive 3, so we get 45. So now we just want to find two factors of 45 that add together to give negative 14. Alright, so they're either going to both be negative, or one might be negative, one might be positive. Well, let's look at the factors of 45. We have 45 times 1. We have 3 times 15, which we just used. And then 9 times 5. So out of all of these, the only combination that works together to give b equal to negative 14 is if I take negative 9 and negative 5. So negative 9 and negative 5 multiply together to give positive 45, and add together to give negative 14. Alright, so you just have to look at all the factors and see which combination you need to get that b. Alright, and again, now I'm just going to replace my b with this 9 and this 5, so 15x squared. And now we have a choice to make. Do I want to write minus 9x minus 5x instead of this, or do I want to write minus 5x minus 9x? I'm going to write minus 5x minus 9x, and the reason for that is I know I'm going to do factoring by grouping, so I just want to keep the things that are similar next to each other. So this has a factor of 5 in it, and this 5x already has a factor of 5 in it, so I'm going to put those closer together for factoring by grouping. And then this plus 3 at the end, this 9 and this positive 3 also share 3, so I want those to be closer together. Alright, so now I replace my minus 14x with my minus 5x minus 9x, and again, factoring by grouping, I'm going to group these like that, and then factor out the greatest common factor from each pair. So this first pair I can factor out a 5x. Alright, that leaves me with a 3x here minus a 1. Alright, and now I know I want to get this 3x minus 1 back here, so I'm going to factor out a negative 3 instead of a positive 3, because if I factor out a positive 3, I'd still be left with a positive here, but I want to get this 3x minus 1, so I'm going to factor out a negative 3. That leaves me with a 3x minus 1, just like I want. Alright, so be smart, just be about this positive or negative. You'll notice if you missed the negative sign, you'll just have to factor that out, but you can do it just in one step by factoring out a negative 3 rather than a positive 3. And now, again, on either side of the minus, or the subtraction, we have a 3x minus 1. So we're going to factor that out, and we'll go for the 5x minus a 3. And again, FOIL this to make sure you get back to what you started with, to make sure you factored correctly. But those are the two methods for factoring ax squared plus bx plus c, so get good at that, because that'll be the most common thing we have to factor in class. Alright, next section we'll look at some special products. We'll actually save some time in factoring some of these, but not all of these.